Hi everyone. So welcome to episode 2. In the last video we talked about MLOps theory. Today we go hands-on. By end of this video you will have a real machine learning model which is running inside a Docker, serving predictions via REST API. We used Python, scikit-learn and FastAPI Docker to make this ML model. So here is the plan. Four steps. Step one, we train a machine learning model and save it to your desk. Step two, wrap it inside an fast API to create the REST endpoint anyone can call. Step three, we write a Docker file to package everything into a container. Step four, we build the image, run it, and test the live API. So before writing any code, let's look at the project structure here. Five files, each one has a single job to do. Model.py trains our ML model and saves it to disk. App.py, our fast API server that loads the model and serves the predictions. Requirement.txt tells pip which Python package to install. Dockerfile tells Docker how to package everything into a container, and README, which is a documentation, which is always a good practice. So you can notice how clean this is. One file, one responsibility. This is how production ML projects are structured. Now we'll go to model.py. So we import load arrays. These gave us like 150 real flower measurement collected in 1936. So think of it as an opening a spreadsheet with 150 rows of data, no intelligence yet, just numbers, raw numbers, and there is no machine learning yet. So we import RandomForestClassifier. This is a pre-built uh, library on algorithm. So thousands of engineers built this for us, and we just import and use it inside our model. So then model.fit. This is a single line, we could say, where all the learning happens. Like the algorithm studies all 150 rows, finds patterns, builds decision trees. After this line, the model knows how to predict flowers based on the inputs we provide. So finally, we save it using pickle. So we should save the model because every time we hit the API, you should not uh, retrain the model every time as we hit the API. So loading a model saved takes milliseconds. So that's MLOps thinking right there. So run it, you should see a model saved dialog. So if you go to VS Code here, let me, yeah. So Python 3 model.py, this is the command which we use to save the model first. Yeah, you could see the model saved here. So then we built app.py now. So if you see app.py, yeah. So app.py, we create this fast API app one line. So we load the saved model at startup. This happens once, not every request. So this is very important in terms of performance of the model itself. The predict endpoints takes the four what do you say float parameters which directly measures the measure of flower actually. So FastAPI reads them automatically and validates them. If you send a wrong type, the FastAPI rejects and no extra code is needed. So we shape the input into an NP array. Scikit-learn needs this format: run, predict, and return the result as JSON. Now let's test it locally using uvicorn. Open your browser. Let hit the docs endpoint, and FastAPI gives your free interactive testing page. So we'll try all the three predictions here, and we should get 0, 1, and 2 based on the input we provided for the prediction. We see these predictions like flower, uh, length, and width, everything. Okay, so let's run app.py and then hit the browser once. Yep. Okay, let's go to the browser. So it's already loaded for us. So let's hit it again. Yeah, if you see this prediction 0, iris setosa, based on the length we provided, it gave back this predictions like uh, to which to which family that flower depends based on the data we provided. So without ML, it's difficult to uh, get the flower family here. So we should go through all the 150 rows of data, and then only we should able to see the flower family. But with ML, it's one single command. We build the ML, so it intelligently responds back with the flower family here. So let's go back to Dockerfile now. Yeah. So we wrap it the fast API and then Dockerfile. So now the Dockerfile, which is the heart of Docker, every line has a purpose. So so Python from Python library we are importing from official Python image. Working directory slash app creates a working folder inside the container. Like it's like navigating to your folders. Copy requirement.txt. So we copy this before other files intentionally. So Docker caches each step. If your code changes but requirement doesn't, so Docker skips reinstalling the packages and faster builds. And run pip install, which install all the packets inside the container, and copy. Now we copy all our code. Expose 88000 labels which port we use, and CMD. This is the on button. Everything above builds a machine, and the CMD is what starts it. So now the moment everything has been building towards 4 commands, and your ML model is live in Docker. Docker build to build your image, Docker run to start the container. So once you start the container, and you should be able to see the ML running from the Docker now. So let's build the container first and then see what happens. So which is running from fast API now. So we cancel this thing, run using Docker. So I'm first building the Docker, building the model inside a Docker as an image. Okay, it's taking time, but I have already, okay, it's running, I guess. Yeah, it's running. Let's wait for the model to build and then we'll see. Yeah, so image is built. Now we run the image of the container. Yeah. So Docker run, which starts the container. The -p flag maps your Mac's. I'm using Mac, so here it maps to 8000 to the containers port. Think of it's a tunnel. Traffic from your browser goes to the port straight to into the container. Okay, so now you see it is starting from the container instead of directly hitting the API, FastAPI. We are hitting the Docker container, which is running the FastAPI. And if you go to browser again and change the values accordingly, so it should give the same values now. 4.5 if you say, and F3 also 4. So if you see, it changes to iris, different family of the flowers now. And now, so here we build the image, run it as a container, and tested API using your local host, and expected responses based on this. So 0 is Setosa, Versicolor, and Virginica. So your ML model is live inside a Docker now. And so that's a wrap on second video. It's a small video, so we go short and speed on every video. So you trained a machine learning model, wrapped it inside a FastAPI, containerized it with a Docker, tested it live. That is a real MS workflow, not just theory here. And here is a big picture. So what you just build is the same pattern used by banks for fraud detection, by any OTT platform for recommendations, by hospitals for diagnosis. You just did it with flowers to keep it simple, and the skeleton is identical, whichever platform we use ML models. So in the next video, we'll try to push exact content to AWS, deploy the cloud, accessible from anywhere in the world. So if this helped you, subscribe and drop a comment below. Tell me what you want to see next. See you in the next one. Thank you.